Engineering Eng. PDF document of this video is on engineereng.com.
Hello friends, in this video I want to talk about how we can find the roots of any polynomial or function in MATLAB. First of all, our most basic method of finding roots is a method we call roots, which means root in English. We will try to find the roots at first using the roots command. First of all, we write our classic commands again in all lessons, as in all lessons. For example, how do we do something? Let's first see what to do logically and validate it in MATLAB. For example, what are the roots of equation like x squared minus x minus 2 equals to 0. So if you remember, we were factoring when we asked which x values would provide 0 when we put them in places. So we equal 2 to 1. Since minus is greater, I put minus in front of the larger number 2 and plus in front of 1. If you remember, when we write x, we were finding the roots by setting them equal to 0. This is my goal in general. It doesn't necessarily have to be a real root. For example, in the equation x squared plus 2 multiply x plus 1 equals to 0, it is separated as plus 1 plus 1. Here the x double root is just minus 1. There may also be a non-real root. For example, let the equation be in the form of x squared plus x plus 1 equals to 0. What are the roots of this, guys? If we apply the rule minus b minus plus in the root b squared minus 4 multiply a multiply c slash 2 multiply a, the coefficients are a, b, c. Since a, b, c equals to 1, becomes minus 1 plus minus in root 1 minus 4 slash 2. Here we find our roots as minus 0.5 minus plus in root 3 multiply j. Let's see all of them now. Let's see the non-real roots, especially with the first equation. Of course, you could write in root 3 as 1 comma blah blah here. Let's see them now if you wish. First of all, how is roots used? It has a very simple use, but it saves MATLAB, frankly. Sometimes you may not find the roots of something, therefore it is very important for us. So now we need to define the roots in an array. From first, let's see the roots in an array. I typed array underscore cookie. I use such a name to see if we could type a random same, so it doesn't matter what displays is. The goal is just give me a name here. Now if you want, let me write here, my goal is to find the roots of x squared minus x minus 2 equals 0 right now. If this is my goal, on the way to this goal, I need to write coefficients into this array. If this is my goal, I have to do this. You know that this flag is used to create an array. You start by writing the coefficient of the highest grade term into it. MATLAB detects this automatically. If you say how he perceives it, he comes from the far right, so he accepts minus 2 as x squared 0. X upper 0. It doesn't matter whether x or a. It accepts a upper 0, for example, and increase it by itself, respectively. In this way, it roots perceive that you are typing the equation, especially that part. So it says that minus 2 multiply x upper 0 only has minus 2 because it is x upper 0 equals to 1. That it increased by 1. So it says there are minus 1, x and 1 multiply x upper 2. Well, how would it be? I wrote it like this. For example, let's say this x upper 3. Then I was going to write it as follows. Since there is no x squared in between, I have to specify it or it can't detect. I have to write like so the coefficient of x upper 3 is 1. I write 0 because x upper is not a term. It goes -1, -2. That is 0 is important. But for now, I just wanted to find the roots of x squared minus x minus 2 equals to 0. It's as simple as I created it. The rest is very simple. They're using roots commands. You are using the roots commands. In it, you write with whatever you gave the same of the array. I just copied it. I say find the roots of this. Logic is even that simple. What is my expectation from roots? And I wrote the same. I expect the roots to be 2 and -1. Let's see if it will 1. Let's give it a name for this. As you can see, we found the roots as 2 and -1 like this guys in lesson 13.1. Now here we are adding this really polynomial, but in the polynomials I did not give in the previous video. The roots are also in a different method, more preciously we can find it with an easy command I want to talk about. I'm going to new script file. I'm opening, that's why. I'm taking those classical commands and typing them again. We write in this way. There's something called polyint command. Again, sims is let's show x as a symbol. You can get the integral with the polyint command like this. I wanted to show the polynomial while I was telling it. You apply the polyint command as follows. Before, let's show you here again. For example, let's say you are going to integrate something like this. Let's say you will integrate 3 multiply x squared minus 2 multiply x plus 2. We integrate this with respect to x. Let's write the result immediately. Of course, I deliberately wrote this. X upper 3 minus x squared plus 2 multiply x is the result of this. This is also logic in the roots in the polyint command. So the coefficients of the array are x squared comma x and x upper 0 should be written according to the term. For example, when we say a-line array, we will define the polynomial in this array A. You will define the coefficient of the term x squared as 3, the coefficient of the term x as -2, and the coefficient of the term x upper 0 as 2. The result will be the following. This will be the result, and a new array will come as a result. Look at the result in this array. There are x upper 3 and x squared and x. So I write to the mode x upper 3. I wrote down the coefficient x squared as -1. I wrote down the coefficient of x upper 0 as 2. But if I turn it off like this, for now 1 in 1 minus 1 to represent x squared, but I know that give x upper 3, and because there is no term with x upper 0, I will write as follows: 1 minus 1 2 0. When this result comes, I will able to understand that is the result of it. So it will actually run it this way with the polyint command and find the result 1 minus 1 2 0, and I will understand that I found the coefficients of x upper 3 minus x squared and multiply 2 multiply x. So when MATLAB gives me minus 1 minus 1 2 0, I can convert it to x upper 3 minus x squared 2 multiply x, because I know how this translates into that. So if you see a result like this, can't you say that constant coefficient is this minus 2x, that is minus 2 squared, and that is x upper 3. I mean, you find the same this way. So now let's see if we can find the result of integral with coefficients 3 minus 2 2 with the operation in MATLAB. We say sims x because we will find it with respect to x before. Later, let's define a square. You will write a coefficient into this array. I say I will integrate 3 minus 2 2. I 3 multiply x squared minus 2 multiply x plus 2. So I wrote a equals to 3 minus 2 2. Did I write it right? Let's say again, I wrote it right. Yes. When I run this program command, I expect to find 1 minus 1 2 0. What did I say? And after finding in this way, I convert it to x upper 3 minus x squared plus 2 multiply x plus 0. So this is in the logic of division. Therefore, if we run polyint common according to A here, we should find it easily. If you want to find it, let's call it lesson 13.2. As you can see, 1 minus 1, 2, 0. I see this here now. I count from the far right. I say x upper 0, x upper 1, x upper 2, and x upper 3. I say 1 multiply x upper 3 type, so this I represents x upper 3. Since this is x upper 3, I reduce it by 1. I typed minus 1 x squared. I don't write minus 1, the minus x squared. Then I drop from x squared to x. I type 2 multiply x, and I say plus 0. I say this is a result. So is it always 0 from coefficient here? Now, for example, if I think it backwards, if I integrate it, this comes up. If I integrate x upper 3 minus x squared plus 2 multiply x plus 5. We say C integral coefficient. If you want to add C, you can add in the MATLAB like this. When you find the constant coefficient and say whether it is 5 or not 0, you would specify that constant coefficient here. Now it will add 5, not 0 here. He will add his constant coefficient, that is the integral constant, by making 0 to 5. Let's show it. It's going to make the 0 over there 5. Whatever you write here, it will write there. Let's try now. As you can see, it make it 5. Now he said that I gave the integral coefficient to the system to be 5. He wrote me the result that way, friends. Now I'm going to another command from now on, guys. This is the solve command, guys. It means solve in English. If you want, let us make an introduction as to how it solves. What does it solve? Let's solve a simple function, find its roots, guys. How do we find it? Let's take a look at it. Of course, by the way, we forgot, guys. We would not just solve this example here. Let's also solve x squared plus x plus 1 equals to 0. Let's write down the coefficient from x squared plus x plus 1 equals to 0. I wrote the roots here. I forgot about for a moment. Let's find the roots here. I'm doing this. You don't hesitate to find the virtual roots as well. Let's run this immediately. We see the roots like this. I think I missed something here, but I did not write. This is how we found our roots. I wrote in root 3 here, but there's also 2 in this denominator. I didn't write it. I also think why there is a value less than 1 here. It makes 0.8. That makes sense to them. Thus, we can find the roots in imaginary way, that is in an I way, guys. Let's go back now. Let's process the solve command. The solve command solves an equation for us, guys. Now I will show you how you solve it. Now you are doing this, guys. You have to write the equation here. It doesn't necessarily mean equation. It will be equation. Okay? We indicate which equation this equation is here. For example, I say I will find the roots of sin x. Of course, the x here has to be symbolic again. I type sims x. I will find it with respect to x, but it has an advantage for me. Whatever I write here instead of x in sin x this time, it gives me a result of 1. For example, the result I'm looking for is 1. I created such an equation. Now I say solve here. Look here, it gives you right way. Instead of saying equation, I say the name should be equation. Solve the equation. The variable of this equation is x. Solve by x. If you thought right, let's try it. I equate the answer from the solution to the answer. What are we waiting for the answer, guys? What are we waiting? So the question says to me, let sin x here equals 1. And you put 2 equation in this way. Equals to equals. So be careful, there are 3 equals at this stage. There are 2 equations. One is to indicate that this equation is the equation. The others are to indicate how much it equals. Now here is the question. What if I write sin x 1 instead of x? The sinus returns 1 in p/2 is 90. So I'm writing for the result p/2 for x. So this is the logic of the event. Solve it according to x raised to 1. Let's figure it out. Let's save 13 here again. Let's call it lesson 13.3. Let's see now. As you can see, our answer came in form of p/2, guys. For example, let's do another example. The exponential function we've written as xx. What if I write e upper instead of the x result is 1? Of course, since e equals to 2, commas plus plus plus, there can be no 1 in any power other than 0. The zeroth power of the each number gives 1, so this must be 0, so the exponential function is equal to 1. E upper 0 equals 1, because so I'm waiting for results 0 for x. As you can see, let's find it here. Let's see. Okay, I found the answer 0 in this way. We also have a command like this solve here, guys. It can solve two different equations. Let me show you what I mean by opening a new script. Let's copy these first. Let's say new script. Let's stick them here, guys. Now, for example, we have an equation like this, guys. Let's x plus y equals to 3. Let's x minus y equals to 1. So what are x and y? Just think of what you did with your mind. Let's say x equals to 2, y equals to 1, so their sum is 2 and their difference is 1. So x equals to 3, y equals to 1. I know it. Here I will show you how to find them in MATLAB with the solve command, guys. Now there are two equations. There are x plus y equals to 3 and x minus y equals to 1. I show these equations separately first. I say equation x plus y equals 3, show this way. You say equation 2 x minus y equals 1 in this way. Then of course we want the answer. I want him to use solve command while asking these answers. While using the solve command, we create two arrays. One of them will be succession of the equations. Here we will write equation 1 and equation 2 in the first array. We will also collect our variables in this array. Now, since I have two variables in the form of x and y here, I specify x and y with the sims command. Then I say solve. I created the array equation 1 and equation 2 here. This is a two-element single row array. My variables are x and y. You can also separate it with commas here, but I usually leave spaces in array. I set it up that way. Then let's solve it and see what it will give. I accept the roots to be 3 and 1. Let's see if he will. I recorded this as lesson 13.4, guys. Let's see if he will. In this way, he gave it in the form of 1 multiply 1 syntax. Here's the way to go the answer, guys. MATLAB offers us something interesting. I put a full stop to the answers in form of answer point x and answer point y. I write whatever I named the equation here. I'm writing an answer because I said the answer. Since I use x and y variables, I put a period next to the answer and write x and y. We will try to reach the answer, namely 3 and 1. Let's see if we think it's right. I'm working, guys. Look. By the way, where did 3 and 1 come from, right? X equals to 2 because it becomes 2 plus 1 equals to 3. I made a small mistake here. 2 and 1 add up to 3, so I'm expecting 2 to 1 here. Of course, this change I made here did not affect the process because this is a comment. I just make a little mistake and misspelled it. This is how we find 2 to 1, guys. As you can see, MATLAB can solve more than one unknown for us in this way. It can be used more difficult equations, but it can also be a challenge. This now depends on your equation, of course. This is how we learned it, guys. Hope to meet you in another video. Goodbye.